ओके सो प्रीवियस क्लास में हम लोग क्वेश्चंस कर रहे थे. इस क्लास में हम लोग प्रीवियस ईयर क्वेश्चंस पे ज़्यादा फोकस करेंगे and we'll start doing a few more questions and then we conclude in today's session later on. We'll start with second order linear differential equations. Okay. So if you remember, we were doing this question and I left it as a homework for you. So let us see how to do this particular question. So it was given that dy by dx whole square minus d2 upon dx2 is equals to e raised to power y, and y0 was given to be equal to 0 and y dash 0 was given to be equal to minus of 1, and then it was asked that what would be the general solution. What would be the general solution, as in not general but what will be the solution y of x, that was asked. So let us begin with this question at first. It's not that difficult, but मैंने कल भी बोला था how to do this question. What you'll do, you'll simply take dy by dx. मेरे को see, इनमें कोई पैटर्न नहीं बनता. You are not getting any pattern in these questions. So what you can do possibly is uh, you can try looking out for some pattern. Like yesterday I tried with d by dt of that kind of thing. So obviously this kind of thing will happen where, like this kind of pattern on the left hand side. Where do you see? You have to just figure that out. And if you can figure that out, you'll be able to understand. Okay, so what I will do, see, if I have this dy by dx whole square, and if I have this d2 by upon dx2, both of the things are here. So one thing you can do, I can try. Let me try once. If that is successful, then it is good enough. If it's not that is not successful, okay, that will not be successful. One try could have been I would have taken dy by dx is equal to p. Now, if I take it as p, then what will I do of this? Is that clear? What will I do of this? So this will be a problem. So what I can do, I know there would be some function f of x or some function. Let us say, एक काम करो. Let what you can do possibly is just another try I'm giving. Let us see if it works. So what I'll do, I'll simply divide this. So what it will give me, e raised to power minus 5, and you will come to know why I'm doing this. dy by dx whole square minus e raised to power minus 5 d2 by upon dx2 is equal to 1. So this is equal to this. Now what you can do possibly is you can take let e raised to power minus 5, and you know if dy by dx is differentiated, it gives you d2y upon dx2, and if this gets differentiated, it gives 1 dy by dx. So at least this will become easy for you. Let this be equal to t, and I know if I differentiate it with respect to x on both sides, what will happen? E raised to power minus 5 differentiate with respect to x, so it will give you minus dy by dx. Already one dy by dx is present, so you will get a square here, and this minus will come here. Then plus e raised to power minus 5, and again you will get a d2y upon dx2, and this is equals to dt upon dx. Okay, so if you take a negative common, so what you'll get, you'll simply get e raised to power minus 5 dy upon dx whole square minus e raised to power minus y d2y upon dx2 is nothing but minus dt upon dx. So your life has become easy. You can write on the left hand side minus dt upon dx is equal to 1. This is the equation number 1, and how to solve it? You can simply integrate it. So it will give you minus t x plus c1. And what is t, by the way? T is minus e raised to power minus 5 dy upon dx is equal to x plus c1. I already know one thing. एक चीज हमें पता है already कि y dash 0 is given to be equals to minus 1. So what I can do, I can use it here, that y dash 0 is given to be -1 and y0 is given to be equal to 0. So most possibly what I can do, I can use this up here. So at x equal to 0, my dy by dx was -1, okay, and my y at 0 is 0, so e raised to power 0. So I think c1 could come as equal to 1. If I'm not wrong, just see. At x equal to 0, your y dash 0 is -1, and you have y0 is equal to 0, so it will give you minus minus plus. So what you will get, you will simply get, from here you will simply get e raised to power minus y dy upon dx is equal to x plus 1. And from here you can simply get e raised to power minus y, because if you integrate this stuff, you get e raised to power minus y divided by -1. So it will be e raised to power minus y. And this will be x square by 2 plus x plus again some constant of integration. Let us say, name it as c2. And now again at x equal to 0, your y0 is equal to 0. From here also you get that c2 is equal to 1. And from here you get e raised to power minus y is simply x square plus x plus 1. And which supplies you this thing y is equal to minus of ln of x square by 2 plus x. So these questions are quite easy. You can do all these questions in exam now. So I don't think there will be any problem with regards to first order, first degree differential equation, but still I'm going to make you practice a few more questions and then you can try on your own at your own comfort and with the standard textbooks. Okay. So standard textbooks are important because if you want to really take care of your speed and like you have to do things in limited time, yeah? So you need to really take care of that also. Because met question is asked that solution of this differential equation, that is dx upon dt is equal to x square with initial condition x0 is equal to 1 will blow up. By blowing up we mean it will tend to infinity as t tends to. Options are 4. Option number 1 is 1. Option number 2 is 2. Option number 3 is half. And option number D is infinity. So it is asked that what. So it is it is a question of variables. We will simply separate the variables and see x equal to 0. Is that a solution? Is x equal to 0 a solution? No. Why? Because undoubtedly it solves this differential equation on both ends. That is, on left hand side, if you place x equal to 0, the derivative comes to be equal to 0. On the right hand side also it comes to be 0, but you cannot satisfy the initial condition. So here you cannot say that x equal to a constant 0 is a solution. So you can without any tension, without any stress, you can simply take your x on the this side, I mean on the denominator, because x certainly cannot be 0, entirely 0. But on one point, particular point, it may be 0. So I'll still write x cannot be equal to 0. Okay, so now here -1 upon x is equal to t plus c. And I know that at x equal to 0, that is at t equal to 0, your x is equal to -1. It implies c is equal to -1. And if I'm writing c equal to -1, then it is -1 upon x plus 1 is equal to t. And from here you get 1 minus t is equal to 1 upon x. So your x as a function of t turns out to be 1 upon 1 minus t. And clearly this blows up to infinity as t tends to 1. So as t tends to 1, your xt goes towards infinity. So your answer should be A. Is that fine to you? So such easy questions are asked in examination, so not a problem at all. Okay, so you can do all these questions, I hope. few more questions I'll give you, which will wrap up your first order differential equations. So questions, this question has been asked in JAM exam, and it asks that y into dy by dx plus 3x is equal to 0 and y1 is equal to 0. Then the family of curve will be what? Like it will be elliptical, parabolic, hyperbolic, straight line, circle, what? Okay, so this we have to solve. So we'll simply solve it. How to solve this particular differential equation? So this will be y dy is equal to minus 3x dx, and integrating on both ends you'll get simply y square is equal to minus of 3x square plus some constant of integration. And at x equal to 1 your y is 0, so at x equal to 1 y is 0, so it implies c is equal to 3. So simply your y square will be equals to 3 minus 3x square, and so I can write y square plus 3x square is equal to 3, and I can simply divide it by 3, so it will be y square by 3 is equal to 1. So what kind of trajectory does it represent? It clearly represents an elliptical trajectory. This represents an elliptical trajectory. So such questions are asked mostly in the exam. Now, which of the following curves represents the solution of this differential equation? df upon dx plus 2f is equal to 3 such that f0 is equal to 0. So such question is asked. And there are four options given to you. This, or this, or this, or this. Okay, so this is the question asked to you. It's simple. So what we'll do, we'll simply solve this differential equation at first, and we'll see how to see it graphically. So df by dx. So you know uh, this equation is of this form: dy by dx plus py is equal to q, and you know you have to find first integrating factor. Integrating factor will be e to the power p dx. So it is simply e raised to power 2x. And then you can simply write y into e raised to power 2x is equal to integration 3 into e raised to power 2x dx, and from here you will get e raised to power 2x is equal to 3 by 2 e raised to power 2x plus some constant of integration. And at f equal to 0, x equal to 0, f0 is 0, so this will become 0, and this will become simply 3 by 2, and so c would be simply equals to minus of 3 by 2. I hope it is clear. So at the end you will get y into e raised to power 2x is equal to 3 upon 2 e raised to power 2x, then we'll simply get minus 3 upon 2. And from here you can simply write your y as a function of x will be 3 by 2 minus 3 by 2 e raised to power minus 2x. Now see clearly as x tends to infinity, your y would tend towards 3 upon 2. So one thing is clear, at large x it cannot be asymptote to 1 by 2. So this option cancels, this option cancels. Only these two options will have something to say. Now there is only one difference. Here you have this kind of curve, and here you have this kind of curve. Okay. So as x tends to infinity, your function f tends to 3 by 2. Okay, so this is clear. So this option A and C are cancelled. Now you have to make choice between B and D. Now after all, see, if you differentiate it, you simply get what? You simply get 3 upon 2 into 2 e raised to power 2x, so minus 2x, so this cancels out. So you simply get 3 into e raised to power minus 2x, which is certainly positive for all x belongs to 1. And if you again differentiate it, you simply get minus 6 e raised to power minus 2x, which is certainly less than 0. So it will function will be increasing but at a decreasing rate. So if function increases at a decreasing rate and it tends towards 3 by 2 as x tends to infinity, how should be the graph? It should be this way. Is that clear to you? So answer would be B, and D will be cancelled. Is that fine to you? I think such questions now you can do for in your examination. These are not that difficult questions. Few more I'll try and show you what is the level of the exam. So generally, it's not that in each of the topics you're going to get simple questions only, but in differential equations, they're just going to test your calculus and your curve sketching and all those things. It will not be a kind of questions which only depends upon finding solution. Okay, so you have to keep that consideration. This was asked in again JAM exam. It says that consider two particles moving along x-axis. So those two particles are moving along x-axis, and in terms of their coordinate x1 and x2. So one uh, in terms of their coordinate x1 and x2, that is, if particle 1 is told that it is, I'm going to represent it by x1, and particle 2 displacement I'm going to represent by x2. So their velocities are given in this form. dx1 by dt is equal to x2 minus of x1, and dx2 upon dt is given to be equal to x1 minus x2. So when they start moving from the initial location of x1 at 0, x1 at 0 is equal to 1, and x2 at 0 is equal to minus 1. The time dependence. So initial condition are now supplied. Now it is asked that time dependence is of the form e raised to power at for both x1 and x2. Now it is asked what is the integral value of a. What is the integral value of a? So this is asked in your exam. How to solve such questions? So from here you can clearly see that if I add both of them, so I'll simply write it in notation like x1 dot is equal to x2 minus x1, and x2 dot is equal to x1 minus x2. And if you add both of them, so you'll simply get x1 dot plus x2 dot is equal to 0. And from here you can simply say that your x1 dot is equal to minus x2 dot, and you can integrate and you can simply get your x1 is equal to minus x2 plus some constant of integration. And at t equal to 0, you already know that your x1 is equal to 1 and your x2 is equal to minus 1. So simply your c would be equals to 0. Now since c is equal to 0, you know that x1 is equal to minus x2. So if you solve this equation, the first equation, since x1 is given to be equals to minus of x2, so what you can do, simply write x1 dot is equal to minus 2x1. If you solve this differential equation, what you'll get, you'll simply get ln x1 is equal to minus 2t plus constant of integration this, and at t equal to 0, your x1 is 1, so your c1 goes towards 0. So your simply x1 as a function of t turns out to be e raised to power of minus of 2t. Similarly, if you try to solve this question, x2 dot will be equals to what? x1 is equal to minus x2, so it will be minus 2x2. And if you solve this also, you'll simply get x2 is equal to, if If you want to integrate, this will be ln x2 is equal to minus 2t plus c. And remember, it is ln of modulus of x. Okay, so whenever you 1 upon by dy, you integrate, you will get ln of modulus. So this will be equals to what? This will be again equals to c will again give you 0. So whether it is x1 or x2, both of them functionally depend upon a function of temperature. They have a functional dependence as a function of time, and that is e raised to power minus t. So clearly, a would be equals to minus of t. I hope it is clear. Okay, so this I think I have made some mistake over x1 dot is equal to x1 minus x2. So minus x2, yeah, I see. I think. You just see if there is some mistake. I think it's correct as far as I'm concerned. Because here I have written x1 is equal to x2. Okay, if I solve this, uh, x2 dot is equal to x1 minus x2 dot. So at t equal to 0, but there's some mistake, I think. Achha, a is equal to minus 2 is fine. There is some mistake in the sense you already know that x1 is equal to minus of x2. X1 is equal to minus of x2. So you can clearly here itself write x2 as a function of t will be minus e raised to power minus 2t. From here itself you can do. But when you're solving it, that is x2 dot, if you're writing x1 minus x2, uh, then this negative sign is not appearing, right? I don't know. But acha, at t equal to, oh, so sorry, no? My bad. So what was the case? At t equal to 0, your x2 was equal to minus of 1. Okay, at t equal to 0, if x2 was equal to minus 1, so c turns out to be 0. So from here, ln of modulus of x2 turns out to be minus 2t plus 0. And here modulus of x2 turns out to be e raised to power of minus 2. Okay. Now, we already know that uh, in general, remember that x2 uh, can be both positive and negative. So it can give you both answers, e to the power minus 2t and e raised to power minus 2t. But according to our convention, that is x2t should be equals to minus of x1. So this is acceptable. Please remember, there are times when you make this mistake. So whenever you integrate this, you'll get simply ln of modulus of that. If you're not writing modulus, then there will be problem, because then if you write minus 1 here, if you're not writing mod, then ln of minus 1 will give you a complex valued answer. So all these things you have to keep in care. So in any case, exams question is done. Uh, this will be a would be equals to minus of 2. Is that fine to you? I think it is clear. Okay. So most of the questions I have done for you. Now you just try to do a few more questions from exam and try to see if there is any kind of difficulty you are facing. I don't think there will be difficulty. Only one thing I'm going to tell: just try to do as many as questions from your textbooks like HK Das or some other book. So one question I'm lastly doing. It says that x dy by dx minus xy is equal to exponential x, where y is equal to e square at x equal to 1. So we have to find the solution. simply what we need to do is simply do this dy by dx is equal to minus y equal to 1 upon x e raised to power x. And simply integrating factor would be equals to what? E raised to power minus 1 dx, so it will be e raised to power minus x. So y into e raised to power minus x is equal to 1 upon x into e raised to power minus x into e raised to power x. So this is your integrating factor and this is your q. So integrate, so y into e raised to power minus x will be ln of x for all x greater than 0 plus some constant of integration. And we already know that at x equal to 1, your y is equal to e square. So at x equal to 1, your y is equal to e square. It implies log 1 is 0. Your c will be e square into e minus 1. So your c will be simply e. Now just place e here. So you will get y into e raised to power minus x is equal to ln x plus e. From here you can simply write y is a function of x. It is simply e raised to power of 1 plus x plus e raised to power x into ln x. Or you can simply take things common out. You take e raised to power x common out. Nothing can be taken common. So this is it. So here this the answer would be this. I think it is clear. Okay, so these are some very easy questions, and all these questions are asked in the examination. So you don't get worried about the level of the exam. Level of exam will remain this only. So it is not going to be little difficult at all. So please remember this. Okay, so I hope you're getting this particular thing. So sorry for the interruption. Okay, so the last question I'm going to teach. So last question. So last question I'm going to teach is again asked in TFR only. So again asked in TFR. So question says d by dt of d by dt plus 2 into d by dt plus 1 x is equal to 1. So now you just and also there are initial condition given to you that dx upon dt at t equal to 0 is equal to 0 and x at 0 is given to be equals to minus of r. So what you need to do is simply you just operate this first to this, otherwise you'll make mistake. So you just operate the latter part. So latter part is what? It will be dx upon dt plus x. Now you take this d by dt. So you'll get d2x upon dt square plus 2 dx upon dt and 1 dx upon dt, 3 dx upon dt plus 2x is equal to 1. And now here you can solve it using the second order homogeneous linear differential equation with constant coefficient. I hope you know that, so I'm just doing it for you. 3m plus 2 is equal to 0. This is your auxiliary equation. Oh, sorry, complementary function. You'll simply get m equal to minus 2, m equal to minus 1. So your solution will be x as a function. This is a complementary solution. E raised to c1, e raised to power minus 2t plus c2, e raised to power minus t. Is that fine to you? I think this is clear. Now, that's particular integral. You need to uh, find the particular integral also. So, how will you find? You just take from here. You can just write. Uh, just solve this. I think so. Just try to use these two boundary conditions. So you'll get at x equal to 0, it is equal to minus of half. This is your 1, and derivative will be minus 2c1 minus c2, and it is equal to 0. So if you take the derivative, so from here you clearly know that your c1 minus 2c1 is equal to minus of half. So your c1 is equal to half. When you have c1 is equal to half, your c2 is equal to minus of half. So I hope it is clear. So your complementary function as a function of t would be simply minus e raised to power minus e raised to power minus t plus half. Let's see if I'm wrong somewhere, or c1 is half. I don't know what is the mistake I've made. Just see from here. I think uh, at x equal to 0, at t equal to 0, sorry, at t equal to 0, your x is minus of half, right? So minus of half is equal to c1 plus c2. This is fine. And a derivative, if you want to take, so it will be minus 2c1 minus c2, that is equal to 0. So your c2 will be equal to what? 2c1. Oh, sorry, minus 2c1. From here, it is clear that your c2 will be minus of 2c1. So if you just place it here, c2 is equal to minus of 2c1. So your c1 would be half. If your c1 is half, just place here, c2 will be minus 1. Okay. C2 is minus 1, so you just place here minus 1. So okay, and C2 is half. I don't know what mistake I did. C1 is half. No, C1 is half, right? Minus 2. So C1 is half. So sorry. C1 is half. X as a function of t. This is a complementary function. C1 is half. So just write e raised to power minus 2t divided by 3 plus, sorry, minus, what is C2? Now there would be some particular integral as well. So what is that particular integral? You just find it on your own. So simply you have to take this one. So your function after all remains your, let's just write it this way. So it is like d square plus 3d plus 2. So you have to find particular integral. So I'll simply write 1 as e raised to power 0x, and this is 1 upon d square plus 3d plus 2. And whenever you have to find particular integral of 1 upon fd, and here it is e raised to power alpha. So the particular integral is f of alpha. Just write this as 1 upon 2. So your particular integral will be 1 upon 2. So after all, you have x as a function of t would be simply this. It will be simply this. It will be simply e raised to power minus 2t upon 2 minus e raised to power minus t plus half. If I am like correct, if I think it is correct, so it will be like uh, e raised to power minus 2t minus 2e power minus t plus 1 upon t. If you just think there is some mistake I have done, please see. Okay, so I think this should be correct answer. And I think this sums up your question round on first order first degree differential equation. You just try to practice all these things, and then we'll meet in the next session.